Hello, in this lecture we'll find out the value of line segment X. In the drawing we have triangle ABC. We know that angle BAC, this angle equals to 90 degrees. Angle BAD, this angle equals to theta. And angle EAC is also equal to theta. We also know that side AB equals to side AE. We know that side BD equals to 3 units, side DE equals to 7 units, and we want to find out the value of side EC or line segment EC that equals to X. So in the first step we will draw perpendicular from point A to BC. So this angle equals to 90 degrees, and this angle is also equal to 90 degrees, and we define the touching point of the perpendicular from point A to BC as M, and we will do the ratio of, we calculate the ratio of the area of triangle ABD and triangle ADE. So the area of triangle ABD, this triangle, here the squared bracket is the sign for the area, so it means the area of triangle ABD over the area of triangle ADE. So the area of triangle ABD, the area of this triangle, triangle ABD, will be equal to the base of the triangle, that is actually BD, times the height to the base. The height to the base must create 90 degrees with the base, so here AM creates 90 degrees with the base BD, therefore the height to the base is AM, over 2. So the area of triangle ABD equals to BD times AM over 2 over the area of triangle ADE. The area, it is actually the area of triangle ADE or DAE will be equal to the base of the triangle, that is DE, times the height to the base. And the height to the base, it is actually AM, because AM creates 90 degrees with the base DE, therefore the height is AM. Over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we will have here BD times AM over DE times AM. AM over AM is 1, so AM will get cancelled. And it is given us in the question that BD equals to 3 units and DE equals to 7 units. So we can write here that equals to 3 over 7. So that is actually one way to calculate the areas of triangles ABD and triangle ADE. But we can calculate the areas of triangle ABD and triangle ADE in another way. The other way of calculate the area of triangle ABD is to take the base as AB, so the base will be AB times the height to the base. The height must create 90 degrees with the base, so the height will be perpendicular to the base AB. That is to say, this is the height, and it creates 90 degrees with the base AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. We will define the attaching point between the perpendicular from point D to AB as point O. So OD is the height of to the base of triangle ABD, so we'll define it as edge 1. So the area of triangle ABD will be equal to the base AB times the height to the base, that is edge 1, over 2. Divided by the area of triangle ADE. We'll calculate the area of triangle ADE, this triangle, in another way. Here the base will be AE, so the base is AE, and the height must create 90 degrees with the base AE. So here from point A we draw perpendicular to AE, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point between the perpendicular from point M. No, actually the height must be drawn from point D. The height to the base, it must be from point D. So from point D we must draw perpendicular to the base AE, and this will be the height to the base AE. Here the height is perpendicular to the base AE, so the height to the base is this perpendicular. This angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We'll define the touching point of the perpendicular from point D to AE as point K. So DK is the height to the base AE. We'll define DK as H2. So in conclusion, the area of triangle ADE will be equal to the base of the triangle, that is AE, times the height to the base, that is H2, over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we'll get that it equals to AB over H1 over AE times H2. We know that AB is equal to AE, according to what is given as the question. AB is equal to AE. AB equals to AE. Okay, and therefore AB over AE will be equal to 1. So we left with edge 1 and edge 2. So we calculate the value of edge 1. Here we have the right triangle AOD. In the right triangle AOD, we will get that sinus theta equals to edge 1 over AD. Again, in the right triangle AOD, sinus theta equals to edge 1 over AD. We will multiply this equation by AD and we will get that edge 1 equals to AD times sinus theta. Likewise, we calculate the value of edge 2. Here we have the right triangle ADK. In the right triangle ADK, but before that we define angle EAD as alpha. So this angle equals to alpha according to our definition. And here we will get that in the right triangle ADK, sinus alpha equals to edge 2. Here, sinus alpha equals to edge 2. Sinus alpha equals to edge 2 over AD. Edge 2 over AD. I repeat, in the right triangle ADK, sinus alpha equals to edge 2 over AD. We multiply this equation by AD and we get that edge 2 equals to AD times sinus alpha. Okay, so now we can substitute H1 by AD sinus alpha. AD sinus theta. Here you can see that H1 equals to AD sinus theta, and we'll substitute H2 by AD sinus alpha. AD sinus alpha. So here AD over AD is 1, so AD will get cancelled. So in conclusion, we got that according to this equation, we call it equation number 1. According to equation number 1, 3 over 7 equals to sinus theta over sinus alpha. Sinus theta over sinus alpha. So I repeat again, according to equation number 1, we found out that 3 over 7 equals to sinus theta over sinus alpha. But what is the value of alpha? Here we know that theta plus alpha plus theta equals to 90 degrees because of the fact that angle BAC equals to 90 degrees. From one side, angle BAC equals to 90 degrees. It is given as the question. Angle BAC equals to 90 degrees. But from the other side, angle BAC consists of three angles, theta, alpha, and theta. So the value of angle BAC will be equal to theta plus alpha plus theta. That is to say, it will be equal to 2 theta plus alpha. So from the other side, angle BAC equals to 2 theta plus alpha. So this will be equation number 2. So from this equation, from one side angle BAC equals to 2 theta plus alpha, and from the other side angle BAC equals to 90 degrees. From this equation number 2, we will conclude that 2 theta plus alpha equals to 90 degrees. Here we will subtract 2 theta from this equation number 2, and we will get that according to equation number 2, angle alpha equals to 90 degrees minus 2 theta. So we found out that angle alpha equals to 90 degrees minus 2 theta. Therefore, we can substitute alpha in equation number 1 by 90 degrees minus theta from equation number 2 because it equals to alpha. We'll do it now and we'll get that according to equation number 1, three over 7 equals to sinus theta over sinus alpha, and alpha, according to equation number 2, equals to 90 degrees minus 2 theta. Here we cross multiply equation, but before that we have the trigonometric identity that states that sinus that sinus 90 degrees minus 2 theta, sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we will get that the value, here we have 3 over 7 equals to sinus theta over sinus 90 degrees minus 2 theta. So the value of sinus 90 degrees minus 2 theta, according to this trigonometric identity, will be equal to cosine 2 theta. Okay? And we also have another trigonometric identity that the value of cosine 2 theta is equal to 1 minus 2 times sine square theta. Therefore, we can substitute cosine 2 theta in equation number 1 by 1 minus 2 times sine square theta. We'll do it now and we will get that according to equation number 1, 3 over 7 equals to sinus theta over cosine 2 theta, and cosine 2 theta according to this trigonometric identity equals to 1 minus 2 times sine square theta. Okay. Here we'll cross multiply equation number 1, and we'll get that according to equation number 1, 3 times 1 minus 2 sine square theta equals to 7 times sinus theta. So here we'll open the brackets on this side of equation number 1, and we'll get that 3 times 1 is 3, 3 times minus 2 sine square theta is minus 6 sine square theta. That equals to 7 times sine theta. Here we will add to this quadratic equation 6 sine square theta and subtract 3, and we will get that according to equation number 1, 6 times sine square theta plus 7 times sine theta equals to minus 3 equals to 0. We subtracted 3 also from this equation, equation number 1. So we got here quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in our specific quadratic equation, the variable that we are looking for, x equals to sinus theta, and the coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to minus 3. So we put the data inside the formula for x, and we will find out the value of sinus theta that equals to x. So we get that sinus theta that equals to x will be equal to minus b. B equals to 7, so minus b is minus 7 plus minus square root of b squared. B is 7, so b squared is 7 squared. 7 squared is 49. Minus 4 times a is 6, and c is minus 3. All divided by 2 times a, and a is 6. So here, inside the brackets we have minus 4 times 6 is minus 24, and minus 24 times minus 3 is 72. So in conclusion, we found out that sinus theta equals to minus 7 plus minus square root of 49 plus 72 over 2 times 6 is 12. So inside the brackets we have 49 plus 72 is 121. So I write it down. We found out actually that sinus theta equals to minus 7 plus minus 49 plus 72 is 121 over 12. The square root of 121 is 11, so I'll write it down. We'll get that sinus theta equals to minus 7 plus minus, again, square root of 121 is 11 over 12. So here we will have two possible solutions for sinus theta. The first solution for sinus theta is sinus theta will be equal to minus 7 minus 11 over 12, and the second solution for theta will be that sinus theta will be equal to minus 7 plus 11 over 12. So we'll focus on the first solution. The first solution is that sinus theta equals to minus 7 minus 11 is minus 18. Minus 18 over 12 is minus 1.5. So we found out that sinus theta equals to minus 1.5. And because of the fact that sinus theta accepts values, the function sinus accepts values that are greater or equal to minus 1 and are smaller or equal to 1, and minus 1.5 is smaller than minus 1, therefore it exceeds from the range of function sinus. So it is impossible that sinus theta will get the value of minus 1.5. Therefore this solution is not correct because it exceeds from the range of the values that sinus theta can accept. Sinus theta can accept values that are smaller or equal to 1 and are greater or equal to minus 1. And minus 1.5 is less than minus 1, so it actually exceeds the range of the values that sinus theta can accept. Therefore this solution is not correct. Sinus theta can never accept the value of minus 1.5, so this solution is the incorrect solution. We'll cancel that solution and we'll focus on the second solution, that sinus theta equals to minus 7 plus 11. Minus 7 plus 11 is 11 minus 7 is 4 over 12. So we found out that sinus theta equals to 4 over 12. We'll divide both the numerator and the denominator of this equation by 4, and we'll get that 4 over 4 is 1 and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay, sinus theta equals to 1 over 3. And you can see in the drawing, we know that AB equals to AE. From the fact that AB equals to AE, we conclude that triangle ABE is an isosceles triangle. Triangle ABE is an isosceles triangle because of the fact that it has two sides that are equal to each other, that is to say AB equals to AE according to what is given us in the question. So in the isosceles triangle, triangle ABE, the base of the triangle is BE. BE is the base of the isosceles triangle. Triangle ABE. Okay? And you can see here that AM is perpendicular to the base BE, therefore AM is defined as the height to the base BE again. Because of the fact that AM is perpendicular to the base BE, we can say that AM is perpendicular to AE, therefore AM is the height to the base BE. Okay, AM is the height to the base. AM is the height to the base. The height to the base. To the base BE. Okay, AM is the height to the base BE of the isosceles triangle, triangle ABE. And we have rule number 1. According to rule number 1, the height to the base in an isosceles triangle bisect the base. So I read rule number 1 again. According to rule number 1, the height to the base in an isosceles triangle bisect the base. So here, according to rule number 1, the height AM to the base BE bisect the base BE, that is to say BM equals to ME. BM equals to ME according to rule number 1, because the height AM bisects the base BE. That is to say BM equals to ME. Okay? So we actually know that BM is equal to ME. Here BM equals to ME. BM equals to ME. BM equals to ME according to rule number 1. So if we define BM as Y, then from this equation we conclude that ME is also equals to Y. So actually, we know that BM equals to Y, and ME is also equal to Y. So what is the value of AE? What is the value of BE? The base BE. The base BE, from one side, BE equals to BD plus DE, that is to say BE equals to BD, that is 3 units, plus DE, that is 7 units. 3 plus 7 is 10. So from one side BE equals to 10, but from the other side it equals to BM plus ME, and BM equals to Y according to our definition, and ME equals also to Y according to our definition. That is to say BE equals to Y plus Y, that is 2Y. So we actually found out that 2Y equals to BE equals to 10. From this equation we will derive that 2Y equals to 10. Here we divide this equation by 2, and we get that Y equals to 10 over 2 is 5. Y equals to 5 units. So we can write down that Y is actually equals to BM. So BM that equals to Y equals to 5 units, and ME that also equals to Y equals to 5 units. Okay? So in the next step we will focus on the right triangle, triangle BAM, and on the right triangle, triangle MAE. So actually, in those two right triangles, we will prove that those two right triangles can go into each other. Why they can go into each other? First of all, we know, according to what is given us in the question, AB equals to AE. So AB equals to AE, it is given us in the question. And we just right now found out that according to rule number 1, BM equals to ME equals to 5 units. BM equals to ME equals to 5 units. And we also have a common side, AM is equal to itself. AM equals to AM is a common side that belongs to both triangles. So we actually proved that the right triangle, triangle BAM, congruent, this is the sign of congruent, to the right triangle, triangle MAE. According to side rule. We actually proved that all the sides of the right triangle BAM can go into all the sides of the right triangle MAE. Therefore, we proved that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM equals to angle MAE. Angle BAM equals to angle MAE. angle BAM equals to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can congruent to each other, therefore the corresponding angles, that is to say angle BAM and angle MAE will be equal to each other. And so we can write down, we know that angle BAM equals to angle MAE. So if we define angle MAE as x, if angle MAE equals to x, then from this equation, x equals to angle MAE equals to angle BAM, we'll conclude that angle BAM is also equals to x. So actually angle BAE equals to here angle BAM plus angle MAE. But angle BAM equals to x according to our definition, and angle MAE also equals to x according to our definition. X plus x is 2x. So actually we found out that angle BAE equals to 2x from one side, but from the other side, what is the value from the drawing? You can see that angle BAE, this angle BAE equals to theta plus alpha. From the other side, angle BAE equals to theta plus alpha. So from this equation, theta plus alpha equals to angle BAE equals to 2x, we'll conclude that theta plus alpha equals to 2x. We'll divide this equation by 2, and we'll get that x equals to theta plus alpha over 2. Okay? So here we have angle BAE is equal to x. So this angle, BAM, that equals to x, equals to theta plus alpha over 2. And angle MAE, that also equals to x, is equal to theta plus alpha over 2. Theta plus alpha over 2. Okay? So in the next step, we will focus on the right triangle AME. So I will copy the right triangle AME in a new page, and we will analyze the right triangle MAE. So triangle MAE, the right triangle MAE So this is the right triangle MAE. We have already found out that angle MAE equals to x equals to theta plus alpha over 2. We found out that ME equals to 5 units. We will define AM as edge. That is to say, AM equals to edge according to our definition. So, what is the value of sinus theta plus alpha over 2? The value of sinus theta plus alpha, the value of tangent theta plus alpha over 2 it will be equal to ME over AM. Okay, tangent theta plus alpha over 2 equals to ME over AM. But ME equals to 5 units. We found out that ME equals to 5 units and AM equals to edge according to our definition. So, in conclusion, we found out this will be equation number 1. That according to equation number 1, tangent theta plus alpha over 2 equals to 5 over h. Okay? So, in the next step, we will focus on the right triangle AMC. So I will copy triangle AMC in a new page and we will focus on the right triangle AMC. So, what is the value of angle MAC? It is very easy to see from the drawing that the value of angle MAC, the value of angle MAC equals to theta plus alpha over 2 plus theta. Again, the value of angle MAC equals to theta plus alpha over 2 plus theta. So this is the right triangle AMC. Angle MAC equals to theta plus alpha over 2 plus theta. What is the value of MC? It is very easy to see that the value of side MC equals to 5. That is actually the value of ME. It equals to 5 plus X, that is the value of AC. MC equals to ME plus EC. I'll write it here. MC equals to ME plus EC. And we've already found out that ME equals to 5 units. And it is given us the question that EC equals to X, the value that we are looking for. So in conclusion, we found out that MC equals to 5 plus X. So we can write here that MC equals to 5 plus X. Now calculate the value, but we know that this angle equals to 90 degrees, of course. And according to the rule that the sum of the angles in any triangle is equal to 180 degrees, so especially in triangle AMC, the sum of its angle is equal to 180 degrees. That is to say, this angle that is the right angle that equals to 90 degrees plus the size of this angle that is actually angle MAC plus the size of this angle that is actually angle MCA. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that angle MAC plus angle MCA equals to 180 degrees minus 90 degrees is 90 degrees. We'll subtract angle MAC from this equation, and we'll get that the value of angle MCA, the angle that we are looking for, the value of angle MCA equals to 90 degrees minus the value of angle MAC. Okay, so the value of this angle, angle MCA, equals to 90 degrees minus the value of angle MAC that we have already found out that it is equal to theta plus alpha over 2 plus theta and we know that 90 degrees is angle BAC from one side, but angle BAC equals to 2 theta plus alpha, that is to say angle BAC that equals to 90 degrees equals to 2 theta plus alpha. Okay, here we know that 90 degrees equals to angle BAC from one side, but from the other side here angle BAC equals to from one side to 90 degrees, but from the other side angle BAC is also equal to theta plus alpha plus theta. That is to say, angle BAC is also equals to 2 theta plus alpha. From this equation we will derive that 90 degrees equals to 2 theta plus alpha. Therefore, we can substitute 90 degrees in this equation by 2 theta plus alpha. We will do it now, and we get that the value of angle MCA equals to 90 degrees, that is 2 theta plus alpha minus theta plus alpha over 2 plus theta. Here we will open the brackets here, and we will get that the value of angle MCA is equal to 2 theta plus alpha minus theta plus alpha over 2, and we open the brackets, and when we have minus before the brackets, the plus sign will become minus. So here the plus sign will become minus, so we'll have here minus theta. So here we found out actually that angle MCA, the angle that we are looking for, is equal to 2 theta minus theta is theta plus alpha minus theta plus alpha over 2. Okay, and here theta plus alpha minus theta plus alpha over 2 is equal to theta plus alpha over 2. Okay, so we actually found out that the value of angle MCA equals to theta plus alpha over 2. Okay, I will draw the right triangle AMC here. So we found out that angle MCA, this angle, equals to theta plus alpha over 2. So here, sinus theta plus alpha over 2, tangents theta plus alpha over 2, tangents theta plus alpha over 2, will be equal to AM over MC. But according to our definition, AM equals to H, and MC, we already found out that MC equals to 5 plus X. So in conclusion, we found out that according to equation number 2, tangents theta plus alpha over 2 is equal to H over 5 plus X. And according to equation number 1, we have already found out that tangents theta plus alpha over 2 is equal to 5 over H. In the next step, we will create equation number 3, that is the combination of equation number 1 with equation number 2. So equation number 3 will be tangents theta plus alpha over 2 is equal to H over 5 plus X according to equation number 2 from one side, but from the other side it is also equals to 5 over H according to equation number 1. So in conclusion, we found out that according to equation number 3, tangents theta plus alpha over 2 equals to H over 5 plus X, that equals also to 5 over H. So here we will find out the value of theta plus alpha over 2. The value of angles theta plus alpha over 2 it is actually equals to theta plus, and we already found out that angle alpha equals to 90 degrees minus 2 theta. It is very easy to see it because 2 theta plus alpha, 2 theta plus alpha equals to 90 degrees. So if we subtract 2 theta from this equation, we will get that angle alpha equals to 90 degrees minus 2 theta. Okay? Therefore, we substituted angle alpha by 90 degrees minus 2 theta over 2 equals to theta plus 90 degrees minus 2 theta over 2. So we have 90 degrees. Theta minus 2 theta is minus theta divided by 2. 90 degrees over 2 is 45 degrees minus theta over 2. So we actually found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. Here, if theta plus alpha over 2 equals to 45 degrees minus theta over 2, then if alpha equals to beta, then tangent alpha equals to tangent beta. Therefore, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. And we have the trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. We use this trigonometric identity in order to find the value of tangent 45 degrees minus theta over 2. So according to this trigonometric identity, the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees. Minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. We know that tangent 45 degrees equals to 1, so it is 1 minus tangent theta over 2 divided by 1 plus tangent 45 degrees is 1, so it is 1 times tangent theta over 2. Okay, so actually we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay? We have another trigonometric identity of tangent theta over 2. According to the following trigonometric identity, the value of tangent theta over 2 is actually equals to sinus theta over 1 plus cosine theta we have already found out that sinus theta equals to 1 over 3. We have the trigonometric identity that sinus square theta plus cosine square theta equals to 1. We subtract sine square theta from this trigonometric identity, we will get that cosine square theta equals to 1 minus sine square theta. We'll take a root out of this equation and we get that cosine theta equals to the square root of 1 minus sine square theta. So here we know that sinus theta equals to 1 over 3. So we can write here that cosine theta equals to the square root of 1 minus sine square theta. If sine theta equals to 1 over 3, then sine square theta will be equal to 1 over 9. So it equals to cosine equals to the square root of 1 minus 1 over 9 is 8 over 9. And 8 is 4 times 2, and the square root of 4 times 2 is 2 times square root of 2. Over the square root of 9 is 3. So in conclusion, we found out that cosine theta is equal to 2 times square root of 2 over 3. And we already know that sinus theta equals to 1 over 3. So here we can put the values of cosine theta and sine theta inside the trigonometric identity of tangent theta, and we will find out of tangent theta over 2, and we will find out the value of tangent theta over 2. So according to the trigonometric identity, tangent theta over 2 equals to sinus theta over 1 plus cosine theta, and we know that sinus theta equals to 1 over 3 over 1 plus cosine theta. We already found out that cosine theta equals to 2 times square root of 2 over 3. Here we will multiply 1 by 3 and then we will divide it by 3 in order to have a common factor with this expression, and we will get that it equals to 1 over 3 over 3 plus 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we actually found out that the value of tangent theta over 2 is equal to 1 over 3 plus 2 times square root of 2. Okay, so now we take the expression of 1 over 3 plus 2 times square root of 2, and we will multiply it by 3 minus 2 times square root of 2, and then we divide it by 3 minus 2 times square root of 2, and we will have here in the numerator 3 minus 2 times square root of 2 over here we have expression that is very similar to a plus b times a minus b, and a plus b times a minus b equals to a squared minus b squared. A is a 3, so a squared is 3 squared, 3 squared is 9, minus b squared. B is 2 times square root of 2, and 2 times square root of 2 squared is 8. So in conclusion, in the denominator we have 9 minus 8, and in the numerator we have 3 minus 2 times square root of 2. It is actually 3 minus 2 times square root of 2. Okay, so in conclusion, we actually found out that the value of tangent theta over 2 is equal to 3 minus 2 times square root of 2. So here, now we can solve the equation that states that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So here we will put the value of tangent theta over 2 inside this equation, and we'll find out that tangent theta over 2, tangent theta plus alpha over 2 is equal to 1 minus, and tangent theta over 2 equals to 3 minus 2 times square root of 2 over 1 plus 3 minus 2 times square root of 2 . So here we have tangent theta plus alpha over 2 equals to 1 minus 3 is minus 2, minus and minus is plus, so it is plus 2 times square root of 2 over 1 plus 3 is 4, minus 2 times square root of 2. So we actually got that the value of tangent theta plus alpha over 2 is equal to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. That is, it is equal to, here we take 2 as a common factor out of those two, out of the numerator, and so inside the brackets we will have square root of 2 minus 1, and from the denominator we will take a common factor of 2 times square root of 2, and inside the brackets what is left is actually square root of 2 minus 1. So here square root of 2 minus 1 over square root of 2 minus 1 is 1, so it will get cancelled, and 2 over 2 is 1, so it also will get cancelled, and we left only with 1 over square root of 2. So in conclusion, we found out that tangents theta plus alpha over 2 equals to 1 over square root of 2. Now we get to equation number 3. According to equation number 3, we have already found out that tangents theta plus alpha over 2 equals to h over 5 plus x, that equals to 5 over h and we just right now found out that tangents theta plus alpha over 2 equals to 1 over square root of 2. So here we have this equation, equation number 3. From this equation number 3 we can derive the equation that 5 over h equals to 1 over square root of 2. Here we'll cross multiply this equation and we will get that h equals to 5 times square root of 2 units. From this equation, equation number 3, we will derive also the equation that states that h over 5 plus x equals to 1 over square root of 2. So we'll write down the equation that states that h over 5 plus x equals to 1 over square root of 2, and we have already found out that h equals to 5 times square root of 2. So we substitute h in this equation by 5 times square root of 2. So we'll do it and we'll get that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Here we'll cross multiply this equation and we'll get that 5 times square root of 2 times square root of 2 equals to 5 plus x. Square root of 2 times square root of 2 is 2 and 2 times 5 is 10. So in conclusion we got that 10 equals to 5 plus x. Here we'll subtract 5 from this equation and we'll get that x equals to 10 minus 5 is 5. So 10 equals to 5 units. So x that also equals to CE equals to 5 units. That is the answer to the question, that x that equals to CE equals to 5 units. I'll repeat again. Here CE that equals to x equals to 5 units. That is the answer to the question. So in the next step I will summarize the lecture. Actually, we wanted to find out the value of this line segment x that equals to EC. We have here triangle ABC. We know that AB equals to AE, angle BAC equals to 90 degrees, angle BAD equals to theta, angle EAC equals to theta also, BD equals to 3 units, DE equals to 7 units, and we want to find out the value of line segment EC that equals to x. So in the first step we will draw perpendicular from point A to BC. So this angle equals to 90 degrees, this angle equals to 90 degrees, and we define the touching point between the perpendicular from point A to BC as point M. We also define the angle DAE, this angle is alpha. Then we calculated the area of triangle BAD divided by the area of triangle ADE. Okay, the area of triangle ABD divided by the area of triangle ADE. So what is the area of triangle ABD? Here, the area of this triangle, triangle ABD, equals to the base of the triangle that is BD times the eye to the base that is AM. AM creates 90 degrees with the base BD, therefore AM is indeed the eye to the base. So the area of triangle ABD in conclusion will be equal to BD times the height AM over 2. The area of triangle ABD equals to the base BD times the height AM over 2. And what is the area of triangle ADE? The area of this triangle, triangle ADE, will be equal to the base of the triangle that is DE times the height to the base AM. AM creates 90 degrees with the base DE, therefore AM is the height. So it is the base DE times the height AM over 2. Again, it is the base DE times the height AM over 2. Here, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with dB times AM over dE times AM. AM over AM is 1, so it will get cancelled, and we left only with BD over DE. BD equals to 3 units, according to what is given us in the question, and DE is also equals to 7 units. So in conclusion, we found out that the area of triangle ABD over the area of triangle ADE equals to 3 over 7. But we also have a second way to calculate the area of triangle ABD. The area of triangle ABD will be equal to the base. Now the base will be AB. So it is the base times the height to the base. The height must create 90 degrees with the base, and DO indeed creates 90 degrees with the base AB. So it is AB times the height DO, that is H1 over 2. So the second way to calculate the area of triangle ABD equals to the AB is the base times the height AG times the height that is H1 over 2. In the same way, we'll calculate in a different way the area of triangle ADE. The area of triangle ADE will be equal to the base AE times the height to the base. You can see here that the height to the base creates 90 degrees with the base AE, therefore DK is indeed the height. So it is the height, the base AE times the height H2 over 2. So the second way to calculate the area of triangle ADE is the base AE times the height H2 over 2. So here 2 and 2 will get cancelled, and we left only with AB times H1 over AE over H2. AB equals to AE according to what is given us in the question, therefore AB over AE will be equal to 1, so it will get cancelled. And we left only with H1 over H2. We have to find out the values of H1 and H2. So we focus on the right triangle, triangle AOD. The right triangle AOD, sinus theta equals to H1 over AD. In the right triangle, triangle AOD, sinus theta equals to H1 over AD. We multiply this equation by AD, and found out that H1 equals to AD sinus theta. So we can substitute H1 by AD sinus theta. Then we found out the value of H2. Here in the right triangle DKA, in this right triangle DKA, sinus alpha will be equal to H2 over AD. In the right triangle, triangle ADK, sinus alpha equals to H2 over AD. We multiply this equation by AD, and we got that H2 equals to AD sinus alpha. Okay, so we can substitute H2 by AD sinus alpha. So here AD over AD is 1, and we left only with sinus theta over sinus alpha. So in conclusion, we found out that according to equation number 1, 3 over 7 equals to sinus theta over sinus alpha. Okay? And we know that from one side BAC, angle BAC equals to 90 degrees. It is given us the question. Angle BAC equals to 90 degrees. But from the other side, angle BAC consists of 3 other angles, theta, alpha, and theta. So, therefore, we can write down that we know that 2 theta plus alpha equals to angle BAC from one side, but from the other side, angle BAC equals to 90 degrees. So from this equation, we will derive that 2 theta plus alpha equals to 90 degrees. We will subtract 2 theta from this equation, equation number 2, and we will get that angle alpha equals to 90 degrees minus 2 theta. So, and because of the fact that angle alpha equals to 90 degrees minus 2 theta, we can substitute alpha by 90 degrees minus 2 theta. We did it, and we got that 3 over 7 equals to sinus theta over sinus alpha, and alpha equals to 90 degrees minus 2 theta. Here we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we will get that sinus 90 degrees minus 2 theta equals to cosine 2 theta. Okay, so we can substitute sinus 90 degrees minus theta, sinus 90 degrees minus 2 theta by cosine 2 theta. So in conclusion, we got that according to equation number 1, 3 over 7 equals to sinus theta over cosine 2 theta. Okay, and then we have a trigonometric identity that states that cosine 2 theta equals to 1 minus 2 sine square theta. So we can substitute cosine 2 theta by 1 minus 2 sine square theta. We did it, and we got that according to equation number 1, 3 over 7 equals to sinus theta, and cosine 2 theta equals to 1 minus 2 times square theta according to this trigonometric identity. We multiply the equation number 1, and we got that 3 times 1 minus 2 sine square theta equals to 7 times sinus theta. We open the brackets on this side of equation number 1, and we got that 3 times 1 is 3, and 3 times minus 2 is minus 6 sinus square theta, that equals to 7 times sine theta. If we add it to this equation, equation number 1, 6 times sine square theta, and we subtracted 3, and we, in conclusion, we got the quadratic equation that 6 times sine square theta plus 7 times sine theta minus 3 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to a special formula for x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific case, the variable that we are looking for is sinus theta, so x will be equal here to sinus theta. The coefficient a will be equal to 6, the coefficient b will be equal to 7, the coefficient c will be equal to minus 3. We put the data inside the equation for x in order to find out the value of sinus theta that equals to x. So we found out that sinus theta equals to minus b, b is 7, so minus b is minus 7, plus minus square root of b squared, b is 7, so b squared is 7 squared, 7 squared is 49, minus 4 times AC. A is 6, so it is minus 4 times 6, times C is minus 3. So minus 4 times AC is minus 4 times 6 times minus 3. Minus 4 times 6 is minus 24, and minus 24 times minus 3 is 72. So in the inside the root we will have 49 plus 72. So in conclusion, we found out that sinus theta equals to minus 7 plus minus 49 plus 72, square root of 49 plus 72 over 2 times 6 is 12. 49 plus 72 is 121. So in conclusion, we found out that sinus theta equals to minus 7 plus minus 121 over 12. The square root of 121 is 11, so in conclusion we found out that sinus theta equals to minus 7 plus minus 11 plus 12. So we have here two solutions that are possible for sinus theta. The first solution is sinus theta equals to minus 7 minus 11 over 12, and the second solution is sinus theta equals to minus 7 plus 11 over 12. So minus 7 minus 11 is minus 18. Minus 18 over 12 is minus 1.5. But because of the fact that the range of sinus theta is between minus 1 to 1, so sinus theta can accept only values that is from 1 to minus 1, from minus 1 to 1. And because of the fact that minus 1.5 is less than minus 1, so it exceeds the range of the function that is from minus 1 to 1, and we can say that sinus theta can never receive the value of minus 1.5 because its range is from minus 1 to 1. Therefore, this answer is incorrect answer, and we focus only with the second answer, the second solution for sinus theta, that is actually minus 7 plus 11 over 12. Minus 7 plus 11 is 4, so it is 4 over 12. We divided both the numerator and the denominator by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Then triangle ABE is an isosceles triangle because of the fact that side AB equals to side AE. And BE is the base of the isosceles triangle, triangle ABE. And AM is the height to the base. Why? Because it is perpendicular to the base BE, therefore it is the height to the base. And we have equation, rule number 1, that states that the height to the base in an isosceles triangle bisect the base. That is to say, the height to the base BE is AM. According to rule number 1, the height AM bisects the base. That is to say, the height AM divides the base BE to two equal parts. That is to say, BM will be equal to ME according to rule number 1. BM equals to ME according to rule number 1. And so BM equals to ME according to rule number 1. And if we define BM as Y, then from this equation Y equals to BM equals to ME, we'll get that ME is also equals to Y. So we know that BM equals to Y and ME is also equals to Y. And so what is the value of BE? BE equals to BM, that is Y, plus ME, that is also Y. That is to say, BM equals to Y plus Y, that is 2Y from one side. But from the other side, BM, the value of BE, the value of BE is BD plus DE. BD is 3 units, DE is 7 units. So in conclusion, we found out that BE equals to 3 plus 7. That is to say, BE from the other side equals to 10 units from one side, BE equals to 2Y. From the other side, BE equals to 10 units. From this equation, 2Y equals to BE equals to 10. We will conclude that 2Y equals to 10. We divide this equation by 2 and we will get that Y equals to 5 units. So Y, that is actually equals to ME, is equals to 5 units. And BM, that is also equals to Y, it is also equals to 5 units. So we found out that BM equals to 5 units and ME is also equals to 5 units. Then we proved that the right triangle ABM is congruent to the right triangle AME. Why those two triangles congruent to each other? First of all, we know that AB equals to AE. It is given us in the question. Okay, we also found out that BM equals to ME equals to 5 units. And we have a common side AM equals to itself as a common side that belongs to both triangles. So we proved that triangle ABM, BMA equals BAM is congruent to triangle MAE according to side rule, and from the fact that those two triangles congruent to each other, we will conclude that angle BAM is equal to angle MAE. Angle BAM equals to angle MAE according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles BAM and MAE will be equal to each other. So we found out that angle BAM equals to angle MAE. So if we define angle MAE as x, from this equation we will get that angle BAM is also equals to x. So angle MAE equals to x and angle BAM equals to x. And angle BAE is equal to angle BAM plus angle MAE. That is to say, it equals to x plus x, that is 2x. So from one side, angle BAE equals to 2x. And from the other side, from the drawing, you can see that angle BAE equals to, here, angle BAE, you can see it easily, that angle BAE equals to theta plus alpha. It is very easy to see from the drawing that angle BAE equals to theta plus alpha. So we have here that from one side angle BAE equals to theta plus alpha, and from the other side it equals to 2x. From this equation, theta plus alpha equals to BAE equals to 2x. We will conclude that theta plus alpha equals to 2x. We will divide this equation by 2, and we will get that x equals to theta plus alpha over 2. So x, that is angle BAM, it equals to theta plus alpha over 2, and x, that is also angle MAE, is also equals to theta plus alpha over 2. Okay, then we focus on the right triangle AME. We just right now found out that angle MAE equals to theta plus alpha over 2. We already found out that ME equals to 5, and AM equals to h according to our definition. So what is the value of triangle theta plus alpha over 2? The value of triangle theta plus alpha over 2 in this triangle AME will be equal to ME over AM. ME over AM. But ME equals to 5 and AM equals to h. So in conclusion, we found out that the triangle theta plus alpha over 2 equals to 5 over h. This is equation number 1. Then we focus on the right triangle AMC. What is the value of MC? You can see it easily from the drawing that the value of MC equals to ME plus EC. ME equals to 5 and EC equals to x. So in conclusion, we will find out that MC equals to 5 plus x. MC equals to 5 plus x. AM equals to h according to our definition. And what is the value of angle MAC? The value of angle MAC, you can see it is very easy to see that the value of angle MAC will be equal to theta plus alpha over 2 plus theta. Okay, the value of angle MAC equals to theta plus alpha over 2 plus theta. Here it is angle, this angle that equals to theta plus alpha over 2 plus angle EAC that equals to theta. So in conclusion, in total it equals to theta plus alpha over 2 plus theta. Angle MAC equals to theta plus alpha over 2 plus theta. So here we know that the sum of the angles in any triangle is equal to 180 degrees, and especially it's true in the right triangle. It is true in the right triangle AMC. Here 90 degrees plus angle MAC plus angle MCA. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle MAC plus angle MCA equals to 180 degrees minus 90 degrees is 90 degrees. So here we subtracted angle MAC from this equation, and we found out that angle MCA equals to 90 degrees minus angle MAC. So angle MCA equals to 90 degrees minus angle MAC, and angle MAC equals to theta plus alpha over 2 plus theta. Okay? So we substitute that angle MAC by theta plus alpha over 2 plus theta, and we know that 90 degrees is equal to angle BAC, that is actually 2 theta plus alpha. So 90 degrees equals to 2 theta plus alpha, so we can substitute 90 degrees by 2 theta plus alpha. So we did it, and we got that angle MCA equals to 2 theta plus alpha minus theta plus alpha over 2 plus theta. So angle MCA equals to 2 theta plus 2, we open the brackets, here we have minus 2 theta plus alpha over 2, and minus, we have minus before the bracket, so the plus sign inside the brackets will become minus, so it will be minus theta. So 2 theta minus theta is theta. So in conclusion, we got that the value of angle MCA equals to theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we found out that this angle ACM equals to theta plus alpha over 2. We know that MC equals to x plus 5 and AM equals to h. So we can find out that the value of tangent theta plus alpha over 2 equals to AM over MC. Okay? It equals to AM over MC, but AM equals to h, and MC equals to 5 over x. So in conclusion, we found out that according to equation number 2, tangent theta plus alpha over 2 equals to h over 5 plus x. And according to equation number 1, we have already found out that tangent theta plus alpha over 2 equals to 5 over h. Then we created equation number 3, that is the combination of equation number 1 with equation number 2. And that it says that tangent theta plus alpha over 2 according to equation number 2, it equals to h over 5 plus x, and according to equation number 1, it equals to 5 over h. Okay, then we found out the value of theta plus alpha over 2. The value of theta plus alpha over 2 equals to theta, and alpha equals to 90 degrees minus theta, so we substituted alpha by 90 degrees minus theta, all divided by 2. Here we have theta minus 2 theta is minus theta, so in conclusion, in the numerator, here we have theta minus 2 theta, that is minus theta. So in conclusion, in the numerator, we have 90 degrees minus theta over 2. 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. If alpha equals to beta, then tangent alpha will be also equal to tangent beta. That is to say, from this equation we will derive that tangent theta plus alpha over 2 equals to tangent 45 degrees minus theta over 2. And we have the trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. So according to this trigonometric identity, we will find out that the value of tangent 45 degrees minus theta over 2 equals to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. Here tangent 45 degrees equals to 1. So it is 1 minus tangent 45 degrees over tangent 45 degrees, that is 1. So in the denominator we have 1 plus tangent theta over 2. So in conclusion, we have here the equation that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So the only thing that is left to find is to find out the value of tangent theta over 2. But we have a trigonometric identity for tangent theta over 2. And the trigonometric identity for tangent theta over 2 states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. And we have already found out that sinus theta equals to 1 over 3, and we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We subtract sine square theta from this equation, and we will get that cosine square theta equals to 1 minus sine square theta. We take out from this equation, and we'll get that cosine theta equals to the square root of 1 minus sine square theta. So here we can substitute sine square theta by, we know that sine theta equals to 1 over 3, so sine square theta will be equal to 1 over 9. So we substitute sine square theta in this equation by 1 over 9. We did it, and we got that cosine theta equals to 1 minus 1 over 9. 1 minus 1 over 9 is 8 over 9. And 8 is 4 times 2. The square root of 4 times 2 is 2 times square root of 2. And the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3. And we already found out that sinus theta equals to 1 over 3. So here we will use this trigonometric identity in order to find out the value of tangent theta over 2. So the value of tangent theta over 2 according to this trigonometric identity equals to sinus theta over 1 plus cosine theta, and sinus theta equals to 1 over 3 over 1 plus, and cosine theta, we already found out that cosine theta equals to 2 times square root of 2 over 3. So here we multiplied 1 by 3, and then we divided by 3 in order to have a common factor with this expression. And in conclusion, we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2 over 3. 3 over 3 will get cancelled. And we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. Then we took this expression and we multiplied by 3 minus 2 times square root of 2, and then we divided by 3 times minus 2 times square root of 2. So in the numerator we have 3 times minus 2 times square root of 2. And here we have the expression that is very similar to the algebraic identity that a plus b times a minus b equals to a square minus b square. Here a equals to 3, so a square is 9. B equals to 2 times square root of 2, so b square is 8. So in conclusion, in the denominator we have 9 minus 8, that is 1. And in the denominator we have 3 minus 2 times square root of 2. So all that is divided by 1, we have the same value. So in conclusion, we found out that the value of tangent theta over 2, the value of tangent theta over 2 is equal to 3 minus 2 times square root of 2. Now we can substitute tangent theta over 2 in this equation by 3 minus 2 times square root of 2. We did it, and we got that tangent theta plus alpha over 2 that equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. It will be equal to 1 minus tangent theta over 2 is 3 minus 2 times square root of 2 over 1 plus tangent theta over 2, that is 3 minus 2 times square root of 2. In the numerator we have 1 minus 3 is minus 2, and minus and minus is plus. And the conclusion, in the numerator we have minus 2 plus 2 times square root of 2. 3 plus 1 is 4, so in the denominator we have 4 minus 2 times square root of 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. Here we took 2 as a common factor from the numerator, and inside the brackets we have square root of 2 minus 1. From the denominator we took 2 times square root of 2 as a common factor, and in the brackets we have square root of 2 minus 1. So square root of 2 minus 1 or square root of 2 minus 1 is 1, so it will get cancelled, and 2 over 2 is 1, so it also will get cancelled. And in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So here we have question number 3 that states that tangent theta plus alpha over 2 equals to h over 5 plus x, that equals to h over 5. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 5, 1 over square root of 2. So we can add this to equation number 3. And then we created the first equation that h over 5 equals to 1 over square root of 2. because multiply this equation and we found out that h equals to 5 times square root of 2. Then we created the second equation in the red color, the line in the red color, that h over 5 over x equals to 1 over square root of 2. Here h over 5 plus x equals to 1 over square root of 2, and we already found out that h equals to 5 times square root of 2, so we can substitute h by 5 times square root of 2. Here, in this equation, we substituted it and we got that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Because multiplied this equation and we found out that 5 times square root of 2 times square root of 2 equals to 5 plus x. Square root of 2 times square root of 2 is 2 and 2 times 5 is 10. So in conclusion we found that 10 equals to 5 plus x. So we subtracted 5 from this equation and we found out that x that equals to CE equals to 5 units. So in conclusion we found out that the value of line segment CE that equals to x is equal to 5 units. I will repeat again, the value of line segment EC that equals to x is equal to 5 units. Okay, thank you very much.